So today I want to tell you a little bit about two open source projects that we have at Cloud 66, and they are called Starter and Habitus. Now, before I start, just wanted to kind of get a feel of the crowd. How many of you have used Docker in development? Sweet. How many of you have used it in production? Great. You don't get to raise your hand. Cool. All right. So with that, now that you've used Docker in development, you're probably familiar with a lot of things about layers and Dockerfile and all sorts of things. But just to recap as to what Dockerfiles are and why a starter is something interesting, I'm going to go through a little bit of how Docker images work. So as you know, Docker is a process that runs, and you can bring in images, what we call Docker images, into it, and it will start them as containers, like little processes that are controlled by the Docker daemon, right? These images are built with a recipe. That recipe is called a Dockerfile, usually. So you use a command or an API, something like a Docker build, and then give it the Dockerfile. And what Docker daemon does, it just goes through every single line of that recipe and builds the layers one on top of each other. So if you look at this, if this is a kind of a typical Java application that you might run in a container, if you say Docker build, you start from a base image, which you usually pull out of a repository somewhere, and it's kind of a basic, like I say, Linux kernel, and then you have, say, Ubuntu or Debian or something on top of it, and then you install Apache, Java runtime, Tomcat, for example, then your war file, and this is your runtime, which is basically where your application operates. So each one of them are read-only. So every time you run a line in that command, you end up, every time there's a line in the Docker file, you end up adding one layer on top of each other. What it means is every time you add a line, you end up with another layer. The alternative, the other side of this is, if you add something, let's say your private SSH key, then you end up with that buried in the layers forever. And somebody can go and say Docker push, which goes to the public repository, and then there you have your public private key in the public. We're pretty good in terms of remembering not to commit our private keys into Git repositories, but I've seen these kind of mistakes quite often. Now, why did we start it? So that's the kind of a write-up of how Docker files work and what Docker images are. So if you look at this is a Ruby on Rails application. There is nothing specific about Ruby on Rails. If you're not familiar with it, that's absolutely fine. If you're a Node.js guy or Golang, it doesn't matter much. But what it does, this is the base image, which is Ruby latest, and this comes from some place called Docker Hub, mostly. And in there, you might have multiple images all the way down to the kernel, Linux kernel, but this brings all those layers up, and then you build layer on top of each other, so it's kind of reversed, inversed in terms of the order. We do an update and get install the build essentials and Node.js for this, and then we set the environment variable, then we create a directory based on that, we set our work directory to that, add a gem file, which you can think of it in kind of a Ruby world, is like your npm package, is the way you get your dependencies to your application. Bundle install, which is like npm install, or get your packages installed on that, and then add a whole application into the Docker image. Is everybody comfortable with this? Do I need to go into more detail of it? All right, great. Now you spot some things here about what I call like very well-known best practices of putting a Docker file together. The first thing is, as you can see, we're running all the app update, install in one line. Now you probably notice why, because every time I do one of these, another layer is added on top of each other, so you just want to do it one with all the adds and removes probably in one go. Another thing that you notice here is that although this gem file star clearly lives in the current directory, I'm adding it before adding this. You might say, when you add everything into this folder, you're adding gem file into that folder as well. Why do it 2 lines above? The reason is, again, goes back to the basics of Docker images. Because you're more likely to change your application than change the dependencies of your application. Because of that, I add the dependencies, which are very infrequently changed, hopefully, then run the dependencies that gets it and pulls it from public repositories, for example, then run the application. Which means every time I go and check my application, edit my application, add some, like fix a bug or something, all these layers come from a cache, only this command lines, and this layer gets updated, which means my Docker build becomes much faster. Another thing that you'll see here is this bundle install, or npm install, or any package that you might have, is going to require, potentially, some secrets. If I have a private repository as a dependency of my application, I'm going to do a git pull, basically, as part of this command, which means my Docker daemon, which is a standalone, think of it as a Linux instance, standalone instance, will require to have that secret to do a git pull. But we just talked about this, that if I add my secret here, that secret is going to be there forever. So that's another thing that we'll talk about a bit later. So now that's kind of the basics out of the way. A little bit about a starter. So what's a starter? A starter is basically a simple way to generate a Docker file based on a source code. Simple as that. You have a source code, you don't know how to start with Docker, or you just don't want to do the old boilerplating of it. You run a starter, which is an open source application, written in Go. You can check it out on GitHub. You can contribute if you're into Go. You run it against the code repository, against the code folder that you have. What it does, it goes and runs some cursory checks on the application. It looks for indicators as to what language or framework this application is written in. So it might find a gem file. It says, it's probably a Ruby or gem. It finds a package JSON. Is it NPM? Or it could be something to do with Java. And it detects those, or it's framework in PHP. It finds those signals, and based on that signal, goes into an execution path that goes and discovers more for that framework. So if you do something like PHP, it then goes and finds all the things about that PHP framework, like where the database is, what's the username, what's the password, what's the database name, or at least the environment variables that point to those. Ruby does the same thing, which you can see in something like this. So for Ruby, Rails, all that kind of rack-based, you have the dependencies in something called gem file. The database credentials are in database YAML. The processors could be in proc file if you come from Heroku. Node.js, same, like play in Java and PHP. And you can imagine that there could be an application that just you run an executable against the folder that you have your code base in, and it goes and detects those things, and then comes up with a Docker file. Isn't that great? So you don't need to care about what packages do I need. And a good example of that could be RMagic, like ImageMagick. If you've used ImageMagick, you know that pretty much the whole universe as a dependency. And figuring that out can be painful. Is the pace okay?
Will it use like the Linux distro that it's being based on's a dependency resolution mechanism?
So
does it try to do its own dependency resolution? It doesn't use the dependency of whatever Linux distro that it's using as the base?
Right. So Starter is pretty dumb when it comes to that, because it has an opinion about what it starts with an opinionated version. However, it works based on templates. So if you look at the code of Starter, you'll see that when it goes and says, this is a Ruby application, and it finds a gem, or a package dependency in Ruby world, that says RMagic, which is the wrapper around ImageMagick. So it seems you're using ImageMagick. Then it goes and pulls all the dependencies in Ubuntu 14.04 that are required to compile ImageMagick. If it finds MySQL, it goes and gets MySQL package, the client side of it. So by that, it just builds a dependency list of that based on Ubuntu 14.04. However, it doesn't mean it's an open source project. It doesn't mean that it's not going to evolve into having better ones. For example, with Ubuntu 16 coming out, or is out, we're going to have to update that, and that's why it's an open source project. Okay. So Starter makes it easy to get started with porting your application into containers. You can get it by doing it, if you are running on a Mac, do install C66 Starter. You can get it from the release folders of the GitHub project. I'm going to show you how it works.
The terminal's way too small to read.
Yeah, I'm gonna. Right. Okay. Anybody who's familiar with Go here? Right. Okay. So once I had the way to hire a Go developer is to get a Java developer, show them Go. Right. So this is a starter code which we probably cannot see much of, but I'm going to just do risky stuff, get the code, build it, and run it right here. So let's see. So here I've got a project. I've called it Docker 101. It's a Ruby on Rails application.
For something?
What's that?
For something? Version 5.0 has been out for a while.
Yeah, I think it's Ruby Rails 4. So I'm going to run it just native as you would do. Okay, let's see what it does. As you can see, this is what it does. It's a simple application written in Ruby on Rails. It has a SQLite database. Every time I refresh, it increases the count. Simple, right? As you can see here, it's running with Rails S on my Mac. Now, obviously I've ran this before because I don't want to get seriously embarrassed here. So I'm going to remove the files that it's generated, and I'm going to run starter here. So I'm running starter here. Can everybody see this? Sorry, let me bring it up. Right. Okay. Is it kind of good? Mm-hmm. All right. So what it does now is detected that there's a Ruby application. In Ruby or Rails, you can specify the version of Ruby that you have in your gem file. In this case, we didn't. So it says, I don't know. Do you want to use the latest? I'm just going to go and say 2.0, just because that's safer. But probably I have it in cache. It couldn't find any databases because it's using my SQLite. And I'm going to run it against the application that actually uses MySQL and Postgres and Redis and Mongo, and it actually detects all those. But in this case, SQLite doesn't need any drivers, so it says I couldn't find any drivers. Do you want to add anyone manually? No. And it then comes up with the boilerplate standard lines of code that you need to run a Ruby on Rails application. This one is to blast your database with the schema, and the second one is to migrate your database. These are Ruby on Rails specific commands, not really important in this case. I just want to show the fact that starter now is well into Ruby land and Rails land and actually detects those things. And what it's done is now it's created a Docker file. There, it created a Docker file for me, and it suggests that I can go to Git, add this Docker file, and come into it. So let me see if the demo guys need to help. Okay, so what I'm going to do now is I'm going to use my Docker here to build that Docker file, which is the context, build a Docker image called Docker 101, based on the one that was generated. All right, so what's happening now is these lines are the ones that you saw on that slide. It basically just generated that thing. It's gone there, environment variable, all sorts of things. Now it's running bundle install, which is going to internet, which is the risky part. It's going to get all the dependencies from GitHub, and hopefully you're going to end up with an image that's going to run what I want. Now, while this is happening, this is a Ruby on Rails application. Obviously, you can do the same thing with any language. There's no dependency on this. But all of these are public repositories. So I don't need any secrets to just do a git pull. There's public information. I can pull it down. I don't need any secrets. That's what happens, which gets interesting and kind of manages the secrets for you.
When you run the tool, do you build the tree first? You have all of your binaries. So if I have a Java tree,
yeah.
If I run it on my after I run it after I build the tree. So all the jar files are there.
Yes. So the frameworks that are not supported, as I said, open source project. So there's contributions every day. I know that we support Rack. It supports Node. It supports PHP. 2 frameworks, I think, in PHP. And I'm pretty sure it does play Java as well. I'm not quite 100% how much coverage it has. But obviously it needs to support the hierarchy of the structure of that folder that you have code in there. So if there's like dependencies or places that convention forces you to put environment variables, then it will need to be supported.
What about build systems? Is it sensitive to the build system? Is it looking at the build files?
So that's where Habitus comes in. Because with compiled languages like Java, or with C, or with Go, you have a compiled environment, a build environment, and a runtime environment. And when I'm going to talk about Habitus, that's where I'm going to talk about complex builds, where you run the compile in a compile environment, and then you take the artifacts out, put it into another container, where you actually can manage your secrets, you can manage size of the image and squash it into a smaller size because you don't need all the development libraries and dependencies. Okay, seems to be successfully built, and let's just check it out. So here, Docker 101 created 28 seconds ago, so that's that. Right. So what I'm going to do is now I'm going to run this, and I'm going to go into the container. You're probably familiar with this. What I'm doing here is I'm saying port 3000 inside the container is mapped to the outside of the container because that's where Rails serves the content. And I'm going to go into the container without running it. Okay, so now I'm inside the container. You saw that there was an add./app. This is my app. Right, so app is running. Now here, obviously I need to point to the virtual machine that's running Docker. And there you go. So we started with 10, 12, 13, and now my app is running inside of the container. And what I'm going to do is I'm going to go back, stop this container.
So it's accessing the SQLite that is outside the container?
That's now. You tell me now.
It started with that, so are you running that in another container?
That's yes. The $1 million question. Let's see. It was inside. It's reset to 10. I stopped the container, I started back again, and I'm back to 10. You remember the layers? The red one at the top, that's the runtime. That's the only layer that I can write into. That was what it was writing into. I stopped and start again. Everything goes back in time. Which is a whole new kettle of fish. If you think about persistence, databases, Kubernetes is probably going to have something to say about that. Class 6.6 also. So
is there a way to know which layer is read-only or write-only?
The last one is the only one that you can write into. It's additive. Every time you add something, it's a new layer.
And is there a way to analyze if some certain layer is corrupted because certain times?
Yeah, there are tools out there that you can analyze each layer. You can know what's actually inside each layer, and that's why on the other side of it, if you have a secret like your password or your private SSH key buried inside of one of those layers, and you say add, and then in the next layer you say remove, there's nothing in the last layer because on top of each other you've deleted it. But somebody can go into that layer and look at that layer itself, essentially shave off the top, and that becomes a layer that you can have a look at. Everybody comfortable with this? Are we cool?
No. Yeah, I have
Sorry,
a
I'm just
question regarding the base images. So what, as a best practice, initially Docker community suggested to use Debian Jessie as a base image for building everything. But now the Alpine, is there a way to easily convert from one base image Docker file to another one?
So there are a couple of things here. Base image where you use it, and also base image for development. So there are kind of two things when we talk about base image. What you're talking about is basically base image.
Yeah.
Almost, for the sake of argument, base image like vanilla,
yeah.
Big Bang. At the other end of it is the base images for frameworks, for example, like Go Compile Time or Node.js, where you have the official repositories published by Docker, contributed by the players in the market on that framework, where they publish and host that, and you can do that. What's the best practices around that? Always use a tagged version. Never rely on latest, because things are going to move under your feet, and then something that used to work never does. So that's like the best thing you can do. I always make sure that even if we do something like from this base image, we have a Docker file for that. Instead of having a mishmash of some things are built, some things are just coming down. An example of that would be MySQL. So you have a base image for MySQL, say 5.5 or 5.6. You can always say, okay, here's my Docker compose file, which brings all these components together. My code comes from a Docker file that I build, but on my database, I'm going to just go directly to Docker Hub and pull it down and say, MySQL colon 5.5. I always make sure that we have it from there and we build it. It might be just a one-liner, it doesn't add much kind of overhead, but then I have control over this.
Yeah.
That I can be in charge of that, change the maintenance. It's like forking on GitHub.
Yeah.
As for the base image, what you're talking about, which is like with the BusyBox or is it in Alpine, it very much depends in horses for horses. What do you actually want to do? What you want to achieve? If you want to get to the minimal size, for whatever reason, bandwidth is scarce, or you want to push it down to in terms of things, you put it into like a device at somebody's house or something. Obviously, going with size, but there comes the challenges of everything you need to add and install. You need to pretty much make sure that your build process is separate from your runtime process, because there's a lot of things that you need to build, like make, like GCC, which you don't need for running. So you need to have a process. That's why we did Habitus. And the other thing is you make sure that the native libraries that you want, if you have any of those, are available for that flavor of Linux. So if you're using something like 0MQ, you need to have that kind of base layer there. And also, the architecture that you run that Docker image on. So if you want to run it on ARM processes, for example, you need to make sure all the things that are compiled are ARM compatible, as opposed to x86s.
Yeah.
Okay, sorry, you had a question.
I wasn't sure it went by so fast. Whether I saw you do a git add, did you actually do a commit as well in that script?
No, I didn't.
Okay, because I was going to say committing without a message is
No.
going to make a mess on your code base.
Yes. No, we didn't. It's a suggestion that is out there, basically. And the reason for that is this. So if I run it now, if I run it again, so I'm going to come out of the container. So I'm going to run starter again. And it says, you have a Docker file already. Unless you force it to overwrite.
Okay.
It wouldn't. Because the idea is this. It gives you a template. It gives you the boilerplate. You then most likely go in and say, well, hang on. Here I need this intricate thing that I need to add. Mm-hmm. It's the base. It's not necessarily a magic way of Dockerizing everything. Sorry.
It doesn't put an entry point in yet, don't do that.
Entry point?
At the end to start the...
Oh, right. No, it doesn't. It doesn't. At least for Rails it doesn't. So as you can see, it's exactly what was there. We do detect, the code detects, I know for Rack, for example, what kind of web server you use. Are you using like WebRick or Thin or Unicorn or Puma or whatever else that might be. And it depends on like Tomcat for Java, whatever. So the application server, the web server, depending on the framework, it does look at that. And it also looks at the ports that you're potentially using as the default port. But it cannot be sure. So it's better to be more conservative and say something like that. So you saw me adding, going into the box and doing that. What I can do, obviously, is to do something like this. And I'm doing this B0 because, obvious reasons, it needs to be bound to. I'm going to take out the interactive part.
Rails C console.
No, wrong.
No, actually, I think I'm making a mistake.
It's not bundled.
Probably
Docker 101. Wrong container name.
Sorry. Thank you. Okay. So now I should go back to 10. There we go. So you can actually add that command into a.
So does it work less if your MySQL database? Does it also do Docker compose file? In terms of
That's a very good question. So it does more than that. So as you can see, it does a slightly more than that. So you can actually generate a Docker compose based on that. And how does it do it? It's kind of an interesting because most cases that we've seen is people come from Heroku or somewhere like that, where proc files or format or something, where there's a proc file that says, oh, this is my web, this is my background 1, this is my background 2, this is like, mail sending thing, this is the something. And basically based on that, you find this thing that's there. Obviously, it cannot really be reliable when it comes to dependencies. We add a dependency to database to everything as a link, so you know the build order kind of gets there. But if you have 5 parallel processes, there's very little that we can do in terms of guessing what the dependencies are. For Cloud 66 specific, we do Service YAML, which is very much like Compose, but has production things, has dependencies, as well as like native databases and stuff like that. And if you have anything else, I'm sure there's going to be versions, different versions for different frameworks that you can just spit out those things. So you can actually generate it on Compose as well. Okay.
This generates all the different, like for example, you're talking about Rails, all the different environments, like production, testing, development, etc.
The container contains your code,
Okay.
and depending on what environment variable you actually run it as, it will just run that. Like if you think about the Rails application, you can just say Rails start environment, Rails environment production, or you can say Rails environment QA or test or whatever that might be.
Right.
And that's entirely up to you because the whole thing is in there.
Oh, right. So there's
Yeah. Okay. Any questions about startup?
You mentioned that the Python Django support is experimental. How experimental?
How experimental? That's a very good question. How experimental is experimental? Okay.
Changed 13 minutes ago.
7 days ago. Well, that was me because I was cleaning something. Sorry. Before demo, you have to do your homework, right? Didn't want to be that embarrassed. So, yes. Start with Docker is the website. Hopefully, my colleagues have put something about them supported frameworks. They haven't. I'll ask them. I will get back to you. If you drop your email, I can get back to you about the supported frameworks on this. But if you really want to do Go, which is a cool language in my opinion, I encourage you to check out the code and have a look. Okay, so with that, let me move to, so this is what we've seen basically. Code to starter, Docker Compose, Service YAML for Cloud 66 for development, production, whatever that could be. Now, let's talk about Habitus. So what is Habitus? We were told off by Docker Inc. that we should not call it a Docker build flow tool. It should be called a build flow tool for Docker. So, correction. I stand corrected to the gods of IP and trademark. But it's exactly that. It's a build flow tool for Docker. So why did we need this? This is what something that we built when we open sourced it ourselves. But basically, I have that t-shirt. It's pretty cool. There's no place like 12700. I had actually IPv6 one as well. Cool. Okay, so I'm going to use an example of a Java application or a Go application, just to Go because I'm more familiar with Go, so I'm not going to say something stupid. Hopefully. The idea is that you have a language that's compiled. And you want to compile it in a container and then take the artifact, the build artifact, into another container so you can run it. Why would you do that? First thing, size, obvious. You have a lot of things that are dependencies of a compile time where you don't need them for runtime. That's the first thing. The second thing is attack surface, security. The more things that you add, the more things you have to update, the more things that you have to keep updated, the more things you have to keep secure. For those reasons, and potentially many more, we started working on a project called Habitus, which what it does is exactly that. You dovetail Docker builds. It doesn't do anything magic apart from run this Docker file, then run this Docker file, then run this Docker file. That's all it does. It does some fancy stuff between, like run this Docker file, then go to this folder within the container that you created, pull out this executable, drop it into this folder, so the next Docker file can embed it into the image, like that. Or it can do something like pick up this secret, like HTTP SSH secret, then serve it via an HTTP web server that's only accessible from within the container. So inside your container, you can go and say, curl, pull my secret, do a git pull from my private repository, delete it. And no trace of it will be seen. So you're basically injecting your secrets into the container during the build without leaving any traces. Those are some of the things that it does. And to show you, the project is called Habitus.io. The logo looks like the back of an elephant. I don't know why, but it's fine. So this is an example of what we call a build YAML file. If you drop it in a folder, it will be used. And I'm going to just make it slightly bigger. Everybody can see this. So here are the steps. It's a Go language. It's actually a real thing. Builder and deployment. So builder is a step called builder. The Docker file for it is dockerfile.builder. I have secrets here that I'm going to use. And these are the artifacts that will be picked out of the compiled thing by the end of it. Then the cleanup command is go to this and delete this one. And I'll tell you about the cleanups. Then deployment starts. Same with another Docker file. This one depends on the previous step. And then there's a last one, uploader, which depends on the deployment. And it goes, uploads the compiled thing into S3. Right? Simple. Build, compile, build, put it into S3. Right? So the first thing that you notice here is this cleanup. Cleanup, what it does, once you build the container, it goes and runs those commands on the container. But not only that, as you noticed, and I've said before, when you delete something, it has some traces behind. So what it does, once it runs it, it actually goes and finds this, where this command was, this file was added inside of the layers, and squashes those layers. Basically what it does, as you pointed out, it exports every layer into a temporary folder, and then takes those layers that have traces of this out, and then sticks the rest together. Basically builds another container image for you, squashes everything that has this trace. So it basically does a good job of cleanup. It's slightly risky to do this way. It's better if you're dealing with secrets to do it that way, which I'll get to. But this is one way of getting there. The reason it's risky is if you don't run your build with Habitus, you essentially end up having secrets in your image. What secrets do is this. So you have a type of secret which is file, and at the moment I think it only supports file. It goes to the environment home, you know what that means. SSH gets my private key. And then if I want to access it, I can have a line here that says wget, write it into this folder. Now go to the host on this port, which is Habitus port. Get the ID RSA, which was the name of that secret. Change the mod of the file so I can use it, do a git, like test the accessibility basically, and remove it. And because I'm doing all of it in one line, by the end of it there is no trace of it. And that way I'm just giving secrets to my build. And this git-t, SSH-t could be git pull, it could be bundle install, npm install, whatever that might be. The name here for the API, IDRSA, is a convention-based one, is the name of the secret. And you can have multiple of those if you want.
With that, you wouldn't need to squash the image because
Exactly.
it was never in there.
Exactly. The other thing that it does is about dependency management. So if you have a complex build that has 20 steps and some of them depend on each other, basically what it does, it counts the number of cores that you have and then builds a dependency tree and then runs them step by step, and the ones that it can run in parallel will run in parallel depending on the number of cores that you have in your box and everything else. And it also can run multiple builds of the same project in parallel by assigning it a session ID, which is perfect if you want to run it in a hosted environment. So if you have a build server, and your developer just keep committing stuff, and there's a continuous development, continuous integrations process that pulls the commits in and runs them, you might have the same Git hash being built 3 times, which means you need to be able to run them in parallel. And the reason it's important is because all these images end up in a repository, and you don't want to overwrite each other. So it basically uses a random session ID which uses as a tag, if you don't specify an explicit one, it uses as a tag so you can trace every container that's built, any image that's built, all the way back to the developer who committed the lines into it that went into this build. And that's basically one of the cool things that it does. Now I'm going to run a quick demo before I disappear. So here's Habitus. Again, I'm going to do some Brave stuff.
Is that a tool that tells you what Git branch you're on? It has master there?
I think it's a bash script that I...
ZSH.
It's what- yeah,
What's it called?
ZSH.
ZSH does that?
ZSH does it.
Yeah, but this is just normal. This is not ZSH, but it's a relay that's given result of a lot of Googling that I had to do together. So I'm not going to share it with you right now. But no, I'm joking. So Iron Mountain. What's Iron Mountain? It's just it's a secret management. It's like a vault that we use inside Cloud 66. That you can put your secrets in there, and you can open it only when the processes are coming up, so it sucks out the secrets and then closes it down, so proxy secrets are always in memory. That's a Go language, Go project that we've done, but the reason I'm showing it to you here is that it has a build YAML. So as you can see, this is my build YAML, simple, 2 steps, build and deploy. And the first step is Dockerfile Builder, so let's see what's in there. It's Golang 1.5, get the code, build, done. And this is the step that goes to private repositories. We don't have any private ones, so it just pulls the dependencies for Go language. And then, this step, Ubuntu 14.05. So to your point, this could have been BusyBox if all the packages were compatible. But as you can see, this image is way smaller because it only adds the compiled version and a configuration file into that, and that's pretty much it. So for me to run this, I need to do Habitus and run it in sudo. And the reason for that is that when you do a squash, if you have a squash need for squashing, it needs to move the file permissions, so it needs to run in as sudo. If it doesn't detect that it needs it, you won't need to do that. One thing I need to pick up is this. This is basically just passing the environment variables so it can access my Docker daemon.
Purple, it's hard to read.
What's that?
Purple is very hard to read.
Yes, sorry. But it's not very important, that part. Okay, so here's what's happening now. So it's going through every step. It's now, as you can see, it's very familiar face of Docker build. That part's done. Now it's doing running the cleanup. Now committing container, stopping the container. The reason it's actually started the container after the build was done because it wanted to go in and do the squash. Now it's exporting it. So as you can see, it's putting it into a temp folder, which requires you to have the file permissions, hence the sudo.
And for squashing, do you use the Docker squash tool, or is it something?
Yes. So Docker Squash, as an open source project, it's basically ported into the code base. You don't need to have it as a separate install. We actually moved the code base into it and we merged it into the code base with some modifications, so it just works seamlessly with the project. So as you can see, some layers are being removed now. Now we're loading the squashed image back into Docker to have it as an image.
Is there any kind of like concept, just like in Make, for example, where you don't recompile stuff that's already compiled that hasn't changed? Is there anything that when you build this, does it build everything all to start with? I noticed when you were doing the bundle install, for example, it was doing installing for everything.
Yes.
So. Like bundler also.
Docker is pretty good at caching and images because every command that you run based on the context of that image has a hash of the command syntax itself.
Okay.
And that hash basically contributes to it's like a unique identifier. So based on that hash, it goes and pulls it out of the cache if you have it. In this case, I think I might have changed something in the Docker in the gem file in dependency, so it had to run it again.
Because like normal bundle install, it'll say using if you haven't changed
Yes.
stuff, so.
Yes, yeah, you're right.
I only have one bundle, which is, you expect, of course, bundler itself is going to have to be there already, but everything
Yeah.
else.
Exactly. So that's the, I made a change. It was basically, I'd like to think about it as a first time. So now if I look at what was the thing that was built, you can see Iron Mountain was built, and it's not actually 8 megabytes. I think it's 198, as opposed to 760, which was the one before that was built, which was the build one. So we managed to save a lot of space, and more importantly, make it secure so that attack surface is small. And that's Habitus. Again, it's available on GitHub. It's written in Go as well. If you want to take a look, and the project is Habitus.io. You can have a look, read through, see what it does, enjoy, contribute, and profit. Any questions? Sweet. Well, thank you.
All right. So thanks everyone for coming. It's good to be here at Geekdom. This is Geekdom, right? So my name is Joseph Jacks. I'm a co-founder of Gizmatic. We are the Kubernetes company, and I've been involved in the Kubernetes project since the beginning of the project. We all, as a company, sort of got together and thought Kubernetes was pretty awesome stuff back in mid-2014 and decided to start a company around it. Show of hands, how many of you guys have heard of Kubernetes as a software project? Cool, 90% of the room. So this is aiming to be a one-on-one introduction to Kubernetes and not go too much into the weeds. I might have time to give you sort of a quick Hello World node demo at the end, but if not, feel free to ask any questions. What Kosh covered is really sort of day 0 to day 1 in terms of bringing your applications and your binaries into a Docker, friendly format where you can actually take those containers and run them in a cluster of machines and actually take advantage of the benefits of Linux containers. So I encourage you guys to use these tools. That's some pretty awesome stuff in terms of actually generating those images and getting the consistent definitions around your Docker container, Docker files, and managing a proper hygiene around that. I think a lot of people have sort of explored numerous ways to do this. There's Docker's sort of direct indications on things, but I think what Kosh demonstrated is really, really powerful stuff. What Kubernetes does is sort of comes into day 2 or maybe day 1.5, depending on your speed of things, and actually takes those containers and runs them in a cluster of machines. So it's more of the sort of the distributed systems problems that you run into, as opposed to single machine, run my container from the Docker daemon and sort of access that container. Kubernetes is much more around providing higher level abstractions that let you treat many containers in sort of a consistent and easy to understand way. So I'd like to kind of start off with a quote from Doug Cutting. This is the guy who co-created Hadoop, and he said that Google's sort of way out in the future, sending us messages, and I think this is really true. Google uses technology that solves problems at their scale, which is sort of very unique, and beyond most companies' sort of problems and challenges, and you could arguably say in many ways they're sort of 10 to 20 years in the future. So if they send us messages, these are some pretty powerful messages that we can sort of pay attention to when we all eventually catch up to them. We can actually start to really benefit, and there's a nice short circuit benefit there. What's really happening here is Linux containers are becoming really popular ways of packaging software. And as Kosh mentioned, people are increasingly learning about the benefits of these immutable artifacts, which are containers, which sort of compartmentalize your application binaries and let you treat things in a very consistent, repeatable way across environments, using Linux kernel primitives. Docker has obviously popularized this for the average user, for the average software developer or operator, but Linux containers aren't new. They've been around for north of 10 years now, at least in the Linux kernel, and prior to that, in Sun Solaris and FreeBSD jails and many other server operating system software products. And so, Docker came up with a really great API for people to basically use and understand quickly. And so I think that's what's caused Linux containers to grow in popularity. Obviously, Docker isn't just a software project. It's a number of things. It's a company. It's an ecosystem of technologies. Once you have your software and your application packaged in a Docker format, Docker container, you also need to solve a lot of other problems around networking, around configuration, deployment, storage, volume management, scheduling. There's like a long list of things. And so sort of after containers is when you start to look at those problems and start to figure out, okay, I've got my application services kind of packaged in these container images. How do I make use of those to actually build a scalable data center environment that comprises of these applications running in containers? And so that's really what Kubernetes aims to solve. But I'll kind of run through some of these problems really quickly. If you guys have any questions or if you want to double click on any of this stuff, feel free to stop me. But obviously with containers, you have a level of isolation at the application sort of binary and dependency level, but you don't really have that at sort of the overall application level. So if you've got a front end running some front end web app components and your middleware components, whether it's messaging or some kind of stateless or stateful database service, and then you've got some kind of back-end system. All of these need to coordinate and sort of be coupled together somehow, and isolation is a really big issue there when you're sort of running and scheduling a lot of these things in a cluster of machines. How many of you guys use a scheduler at your company if you're like sort of a developer or operator? Okay, so a few people. If you're not, this is something I'm going to steal from Kelsey Hightower. It really resonates with people. Is like if you're not using one of those other sort of modern, sexy software schedulers, you're sort of using a human scheduler, which is someone who basically says, here's my set of machines. I'm going to sort of catalog those machines and look at the utilization and sort of provision that for someone, and then basically they deploy their software on that machine. It's up to them to sort of manage that life cycle. Kubernetes completely does away with that model and automates the scheduling of not only the software, but also the management of your physical infrastructure, which is becoming more increasingly evident in Kubernetes, but specifically the actual software components and the jobs that basically comprise your apps. So that's the scheduling piece. Lifecycle, you've got things running. How do I know it's running? How long does it run? And sort of what's that overall sort of time span like for that different set of components? How to find a job? Where is something running? How do I know where it is in the cluster? If these things are getting sort of started and stopped all the time and they're ephemeral. Constituency, how do these things relate to each other? If there's a dependency chain of some kind, like how do you actually reason through that? That's another huge problem that comes up when you start running things in containers. How do you scale things? How do you actually scale independent collections of containers that make up certain application components? Or how do you actually scale an app itself, which is sort of, how do you describe sort of an app construct? Those things are also changing. How you actually handle authentication becomes much more complex and granular because the deployment unit is smaller. And so instead of having sort of 5 nodes with your apps deployed on each node, you've got 5 nodes with maybe 10 VMs per node with maybe 100 containers per VM, and you have this huge explosion of access control sort of spaghetti that you have to kind of manage. In addition to that, monitoring, how do you actually manage the uptime of these services and like where things are actually running in a cluster, and sort of what logs are getting spun up or generated, and how do you reason through that? And of course, is something alive? How do you actually infer if something is actually running and if an endpoint is real versus something that's just sort of exiting on 0 or just giving some sort of esoteric indication. So what Kubernetes does there is really tries to come up with a comprehensive set of primitives that are based on Google's 10 plus years of experience in basically solving these problems and sort of working through them inside their organization. So Kubernetes obviously is the name of the project. It comes from sort of a nautical theme of ships and pirates and so on. It's actually the root word. It comes from cybernetics and governing, so sort of some pretty interesting etymology there around actually what the word comes from, and sort of a helmsman or captain or steersman of a ship. And it's a container orchestrator. It's essentially a way to take these Docker containers after you have them containerized and images built, and actually run them, deploy them in a cluster of computers, a cluster of machines that are sort of logically linked together. So you could have a cluster defined as 2 nodes, 3 nodes, 100 nodes, 10,000 nodes. And what Kubernetes does is sort of solves all of the automation around deployment, provisioning, and scheduling of those containers for you. So you let the system figure out how things are running, where they're running, and how long they're running, and so on. And your interaction interface into that is at a very high abstraction through an API, basically. Kubernetes runs anywhere. In the very, very beginning of the project, it was pretty optimized around the Google Compute Engine environment, but now it's very well supported on bare metal, on Amazon EC2, on Azure, and pretty much every other infrastructure as a service cloud environment out there. The system's also written in Go, so we heard Kash share that a lot of the Cloud 66 projects are actually written in Go as well. This is a super popular programming language that Google created 7 or 8 years ago, I believe, and it's taking the world by storm and sort of provides a lot of primitives for multi-core, multi-processor type hardware architectures that are becoming more prominent today in the sort of computing landscape. Obviously, also open source as a software project. Any questions so far as I'm going through some of this? Nope. Okay. I'm going to quickly run through this, go through some of the primitives, and then hopefully we can spend some time on the demo, kind of get some hands-on stuff going here. Kubernetes Orange, I mentioned that Google had a system internally that they based Kubernetes off of. That system is called Borg, and it's been in existence inside of Google for well over 10 years. Google has historically been very secretive about this system. They haven't really shared much about it publicly until very recently. They actually released a white paper on Borg, I believe in February of this year. It might have been December of last year, but very recently. That sort of describes what this system does, and it's very specific to Google's infrastructure. So Google has homogeneous data centers. So everything's consistent from the kernel all the way up to the top of rack switch. And so everything is the same, right? So they have a software system called Borg that sort of automates the provisioning and management of all their software artifacts. And it's a bespoke system. So it's sort of written for their types of apps and workloads and semantics. A lot of people ask, why didn't Google open source Borg? Why didn't they just give that to the world? Where it's a couple 100 million lines of C++ and like a super huge hairball of 50,000 features, and it really wouldn't be useful for anyone else that didn't have sort of Google's specific infrastructure. So hence building Kubernetes, which is sort of a distilled version of Borg in that system to sort of provide a lot of the benefits of Borg to anyone. So it's sort of running from a local developer laptop machine all the way up to a large-scale data center. Any questions so far? No? Okay, keep going. So Kubernetes design principles. This is sort of continuing on from the concepts that I talked about earlier. Everything, or almost everything in Kubernetes is declarative rather than imperative. So in prior generations of sort of automation technology and configuration management tooling, we had things that were very imperative. So you had a sort of set of scripts that would describe sort of a procedural step of things to occur on a collection or a set of machines. Things like Chef and Puppet and Ansible and even Bash scripts sort of describe something, and you have this notion of a mutable state that obviously repeats and tries to correct a diff. But that's very imperative, so you have to sort of continually run that to make sure that those things are there. With a declarative interface like Kubernetes, there's this notion of control loops, which basically look at the current state and rectify that with the desired state that you would describe. And that's constantly repeating. It actually comes from robotics theory, which is very well refined theory in computer engineering, and it's actually something that applies very well to the sort of the physical world. But Google actually decided to apply this to Kubernetes, and so a couple of the founding engineers on the Kubernetes project actually studied advanced robotics in prior lives, and this is kind of where that comes from. Simple and complex. Kubernetes uses the Unix philosophy. There's a lot of different primitives that are isolated from each other that do one thing really well. There's lots of different primitives. to sort of understand all of them would take a lot of time, so you really shouldn't. If you're new to Kubernetes, which this talk is about, you should really just try to understand the most common critical primitives that you'll be using on a frequent basis and sort of become comfortable with those. And then over time, you can sort of dig into things that are more esoteric and like less often used. Modularity, there's lots of these things that are sort of independent from each other. Each primitive in Kubernetes, most primitives in Kubernetes have their own APIs that you can communicate directly to, and their own interfaces to extend. Obviously, there's lots of lessons taken here from the way Go as a programming language is sort of encouraging people to sort of cleanly separate interfaces and functionality, which is great. Network-centric. So Kubernetes has some really clever lessons around networking, specifically how you actually get to your pods, how you communicate to them, how you get to your containers and communicate to those containers, and essentially how you sort of reason through traffic management in terms of your ingress and egress to your services. Grouping. So there actually isn't a notion of grouping in Kubernetes. What you do is you label things and you query against those things. So you basically apply arbitrary, labels, key value pair labels to any object in Kubernetes. And in order to provide that closed loop, desired state, current state functionality, you basically select against those labels. And so it's a little subtle. It's very different from, deploying something, tearing it down, and deploying something else that's named something else. What you do is you sort of, everything is sort of always living, and in order to really version or iterate through things, you don't really version things, you just sort of deploy new things and take down the old ones. And selectors basically help you do that. And so it provides a level of granularity that's pretty powerful. Bulk versus handcrafted is really the cow versus pets theory, which is sort of you treat everything as something that you can just sort of easily do without, and that's easily replaceable, and try to not sort of develop a strong affinity towards things like naming something like production server version 3 or something. You don't want to you don't want to have things that obviously are tied to some very specific long-lived entity. Although you can do that in Kubernetes now, where a lot of people have been asking about, hey, I've got a specific machine in my cluster that I want containers deployed to. Say it's got GPUs or some specific set of hardware functionality. You can actually do that now in Kubernetes. That's sort of a relatively new request. And open versus closed. Everything is very well defined in Kubernetes in terms of the code. Some of it's not very well documented. We can get into that a little bit later. And those are sort of the primary design principles. Now getting into the actual primitives in Kubernetes, which we'll be playing with a little bit. A container is essentially what Kash was talking about. You've got your Docker containers. So you're after you've built your images, you're pulling from some registry, whether it's a private registry or some public registry of some kind, and your Docker daemon is allowing you to generate those processes of those containers on a host. What Kubernetes is doing is sort of making that distributed, and so you don't have to think about host level management primitives. You think about a cluster-wide or a data center-wide abstraction, and Kubernetes sort of automates the management of your containers across that cluster. What you think about in terms of Kubernetes as sort of the base foundational unit is a pod. And that's, Kubernetes is sort of encouraging people to think at a higher level of abstraction from a container. Containers can get you in a lot of trouble if you sort of use that as your single way of managing things. In a pod, you're basically co-locating or grouping or coupling containers together in a single abstraction. So you could have something that's basically serving data, pulling data. Both of those containers might have very symbiotic functionality. You want those always deployed together, and there's lots of creative things you can do there. As a one-on-one sort of best practice, you can always run one container in a pod. That's totally fine, and a lot of people do that, just sort of quickly get up to speed on the system and not make things too unmanageable or complex, at least initially. You have a quick question? No? Okay. Please ask me questions. I love questions. I love keeping things interactive. Talking at you is much less fun than talking with you and having a conversation. Controllers are actually really powerful. So controllers basically give you sort of a cookie cutter way of deploying replicas of pods. So you could say I want 10 pods, pulling from this specific pod template configuration, deployed in my cluster, and always 10, right? So if for some reason there's 8, that replica will say, well, you got to create 2 more, and the 10 will always be there. If there's 11, it'll kill 1. And so that's what a controller does. There's different types of controllers. The most common one is a replication controller, which basically says, the cookie cutter way of saying, wherever it is in the cluster, I don't care, just make it alive, and those pods will always be there based on their replica count. So that's really powerful. It's a very common primitive. A service is a way to, a service is first of all a horrible name, and I'll say that publicly. I've told Google this many times. They agree. And it's the most vague name for a primitive, really, in a system. But the way I like to sort of encourage people to think about this is sort of if you parenthesize micro before service, it makes a lot more sense. So it's essentially a microservice. And so basically you'd have virtual IP, which is basically your service, fronting a collection of pods. And the virtual IP basically is generated automatically for you. You don't have to think about that. And the selector allows you to describe which pods are actually going to be grouped by that service. And so you've got sort of a selector value there in your service, in your service configuration, which is dynamically generated for you. So that's a super powerful way to basically say, hey, these are my front-end pods, my back-end pods, my my core service 1, 2, 3 pods, whatever you want to call them. And again, you can label these as well. Labels, again, I've been talking about labels a little bit. This is what you do to sort of describe and manage the grouping or the naming of your objects in Kubernetes. And so all of these things are essentially objects. You label them, and again, that gives you a key and a value that you can sort of describe in any way you'd like. What's common is sort of a phase and a name, you basically say, hey, this is my canary set of pods. I want to group all of these together and change something or swap something out, and do the same with production. And that's super powerful. Selectors are the way you actually query against those labels, and you sort of return what those labels are referencing in terms of the objects, most usually pods. So we talked about pods, how those are sort of co-located. I think the term is sort of interestingly contrived. Peas in a pod, or pod of dolphins, or pod of whales, pod of Docker whales. So we talked about this a little bit. Pods are essentially, again, co-located containers. So in Kubernetes, we don't give you the Docker API, the Docker command line directly. We basically abstract that through the Kubernetes API or Kubernetes command line, which is something we can show in a little bit here. But pods basically give you this way to co-locate containers, and if you want to talk to those containers, you can exec directly into containers in a pod and manage them directly. That's not encouraged, but it's possible. And you can also have all those containers easily managed on the same network plane, so that they're all talking to each other in the same localhost namespace inside of that pod. That's something that's really powerful, again, because Google didn't want us to treat our containers as the core unit of deployment. They wanted us to sort of look at application constructs, and pods give us a great way to look at that in terms of the abstraction. Pod networking. So each pod inside of a Kubernetes cluster gets its own unique IP and its own unique routable IP. So all these IPs internally are generated for you from the IP tables proxy, which is deployed on each node in a Kubernetes cluster. So you don't really have to worry about that. If you're setting up a Kubernetes cluster from scratch, you have to sort of think through block ranges of IPs. Typically that's managed for you when you're deploying in a public cloud like Amazon or Google. But the networking is really simplified here. In the Docker world, if you don't have this notion, you have to think about NATing across machines and doing bridging and linking, and there's a bunch of different complexities that come up there. Kubernetes tries to provide a simple abstraction for sort of handling the networking problems. There's lots of challenges as well. We had to think about providing port numbers and assigning port numbers to things, and Kubernetes gives you a really nice way to basically select any port that you want and allow traffic to go into that and go into that range if you want, but you don't really need to be doing that automatically. It's just sort of giving you those unique IPs. And again, because with the Docker world, you've got a bunch of containers typically sharing the same IP as the host. That's where you come up with all these little sort of port management complexities. Again, networking is a big challenge. I mentioned early on in the container world. The networking complexities are not completely solved in Kubernetes. So there's lots of things out there to hook into for managing firewall roles and policies for multi-domain networking extensions and things like Weaveworks, which I believe is mostly DNS based, if I'm not mistaken.
Service discovery is in it.
Yeah.
It's DNS based, but it's layer 2, layer 3.
Right, and a bunch of other layer 3 systems like Calico and Contrail and many others that are easily integrated with Kubernetes. So we talked about labels a little bit. I'm going to quickly skip through this so we can try and get into the demo. But labels again give you this way to sort of assign arbitrary metadata to the different objects in the cluster, and you select against those labels. So you basically have a set of pods here. You can sort of say, hey, I want to get all of the pods that match the app name of Nifty. They're all going to select back and provide visibility for you. And then obviously, if you want to get a little bit more granular and say, just give me the ones with the role front end, it'll serve those up. And this just kind of gives you a sense of how granular you can actually get with things. This is a huge departure away from hierarchically managing things like you had to in the past, to sort of give things distinct names and then actually bring them up manually. The labeling system in Kubernetes lets you think about organizing things in a more distributed manner. So that's pretty powerful. Control loops, we talked about control loops, which is basically this desired state, current state capability, and it basically lets you describe a state of intentions, and Kubernetes sort of manages the conformance to those intentions or that desired state of things. And that's typically implemented in replication controllers. So this is just a quick config of a replication controller. Then you've got the name of your replication controller. It selects against those labels that I was talking about, and you basically give it a number of replicas. So I want to create, based on this pod template that I'll point to, 4 replicas. That replication controller will always make sure that there are 4 stamped pods in your cluster available for you at any time. You can also create new replication controllers and swap between them, which is a way to do canary deploys or rolling upgrades of things. But this is just a quick indication of, we've got four pods running on 4 nodes. Let's say one node dies completely. The replication controller identifies that the current state deviated from the desired state, which is 4, so it's only 3. Replication controller then restarts that 4th pod on another node in the cluster. This is all done automatically. You don't need to think about it. That 4th pod could have easily been spawned on on either node 1 or node 4, but it just got created on node 3 because of just a random algorithm there. There are ways to get more granular and defined with that, to say if you have a pod template that needs to always get deployed on a specific type of machine in the cluster, you can do things like that as well, but this is just sort of the basic example. Services, we talked about services a little bit. This is a group of pods that acts as a single sort of congruent unit, and it's a way to sort of group pods. You're not actually grouping the pods though, you're basically querying them and letting traffic flow to them through the selector in the service. And so it's a little subtle departure from actually sort of giving things a logical grouping and sort of statically assigning them somewhere. Services let you arbitrarily bring in or select against different types of backend pods. So you could have a service basically say, I always want to select for X, Y, and Z pods matching a certain label, but then you could actually change that label selector in the service in order for that service to sort of evolve itself. That's not really a best practice. You typically sort of have a service that always selects against specific pods, and you create a new service. But it's pretty flexible that way. Yeah.
Can you give more concrete examples of what you would place in a pod and versus what you would build as a service?
So pods are basically grouped by a service. So you don't place anything in a service. A pod is basically containing a collection of your containers or one container, and a service is basically just a way to direct traffic to the back end.
You assemble
pods.
them in service.
Correct. Yeah.
Okay.
Right. So basically, you want to have an IP of some kind, whether it's internal to the cluster or accessible from the outside world or the internet, to basically point traffic to.
So you can imagine the pod as, for instance, an application server, a
Right.
database server,
Right.
a cache server, and that forms a pod, and the service is a series of those.
Service would basically be directing traffic to those pods. You could have traffic directed to individual pods, but those pod IPs that are generated by Kubernetes are private, and they're only internal to the cluster. You can't really do that unless you create a service. And there's different types of IPs that get generated in a service. Some of them are private, internal to the cluster, and some of them are external. We can talk a little bit about that when I do a demo where you'll see like a publicly accessible IP in a service is something you might want to serve a front-end service of some kind on.
Yeah. Is the load balancing round robin?
It is, yeah.
Is that configurable?
It is configurable.
Okay.
Yep. Anything else? No? Yeah. Cool. I think that's it for my slides. I didn't want to get too deep into services because it can get a little gnarly. And what I'm going to do is actually follow. So the easiest way I can give a quick and dirty demonstration to you is by using, for me anyway, and my very unprepared machine here, a demo from the Google Compute Engine, Google Cloud Platform service for Kubernetes, which is called Google Container Engine. It's called, it's abbreviated GKE, which is obviously pointing to Kubernetes, but it's Google Container Engine. And this is essentially hosted Kubernetes on the Google Cloud. It's using 100% open source components that you can pull from GitHub and deploy on your local machine using Vagrant or using some other local mechanism. But Google Container Engine is just a really easy way to spin up a cluster and have an easily accessible command line to actually deploy containers into. It also has a local container registry that we are going to use to pull in container images and actually deploy those in our cluster. And for this we are going to basically get the cluster up and running. So what I did before this was pretty much started a project in Google Container Engine. And by the way, this is it's 101. It's really easy to do a lot of this stuff. You can sign up for a free trial of Google Container Engine on the Google Cloud website, and they give you $300 credit, which is enough for a couple months of just a small cluster and playing and toying around with things and actually learning some of the basic primitives. But what we're going to do here is sort of walk you through how I stood up my project and my cluster here. So basically went to Google Cloud into Container Engine, and I created a project, K101. And when I go into this, you can see I've been playing around with this for just a little bit here, but I gave it a name and basically a way to easily view what's going on here. And this is all really really configurable. You can see my utilization is super low. I'm not running anything currently. These are the number of nodes that I'm running in my cluster. So I've got a 6-node cluster here running in the Asia East 1B region, or zone, rather. And I can, directly through the Google control plane here, I can go and SSH into those nodes and sort of mess around, or I can just use the Google Shell, Cloud Shell directly. I can also download the gcloud tool and deploy the local, the local utility, client utility for command line control of this cluster on my local machine. But just for ease of use, I'm going to use the Google Cloud Shell. So what I'm doing here, and again, you can completely follow along with this on your own, is basically setting up my Cloud Shell, which is basically going into it directly here. And once I've created a cluster, which I've already done in my in my container engine here, I can basically, there's my cluster. I can basically start to play around with it directly and pull in applications from the examples here. So I think I've already set my my default compute engine zone. So mine, instead of Central 1B, was actually Asia East 1 for some reason. I can see my config list here, which is basically giving me the breakdown of my Google Cloud components and the project name. So mine is Kate 101.13.15, which you should remember. And from there, I can go ahead and basically create a cluster, which I already did, and then I can go ahead and run. A container. So with Kubernetes, we have a command line, utility called kubectl, which is basically the interface between the outside world and your API server in Kubernetes, and so that allows you to basically deploy objects and manage the lifecycle of objects in a Kubernetes cluster, which is pretty cool.
What are the targets, like where you're running the containers from? What are the requirements, like operating systems or things that need to be there for Kubernetes to run?
So Kubernetes runs on any Linux distribution.
Okay, so as long as Docker's there,
right,
or as long as Linux is there, able to get in and take care of it.
As long as Linux is there. So the way Kubernetes is designed is you basically have, you have a Linux host,
right,
and then you have the Kubernetes components themselves. So you have the API server on one node, and on the other nodes in your cluster, you would have agents that basically control communication between the Docker daemon,
right,
to start the containers on the host and facilitate that for you, as well as manage utilization on the node level. There's a couple of other agents that you have on all the nodes, obviously the Docker daemon,
right,
but you have something called kubeproxy as well, which manages the generation of those IPs.
Okay. Is there SSHing into them, or command and control?
It can, but it's basically giving you a way to sort of arbitrarily generate those IPs for the pods, as well as for the services. So the kubeproxy is talking to the IP tables and user space and the kernel, and in the Linux distro that you're using, and then basically that's giving you the networking and the functionality. You don't need to really think about that.
Right.
When you're deploying a cluster, all those things are sort of pulled down for you, and the binaries are there, and you don't really need to sort of reason through that. You should just focus on kubectl in the way of like sort of give me my pods, where are my pods running, and that sort of thing. There's a few different components in Kubernetes. You really shouldn't have to think and worry about like how they're working and how they're deployed, unless you're running something pretty large scale like in production.
Right. I was just curious on like a bare metal setup, how much prep I have to do on the bare metal nodes to use them with Kubernetes.
Yeah, I mean for bare metal, there's lots of ways to just basically pixie down the components and have Kubernetes discover your nodes and sort of register them, and then get your registry hooked up to that, so you can actually run your containers. But yeah, bare metal is a little bit more complex, so obviously you've got to have like internet access and get all the nodes sort of connected together and make sure they're on the same rack and the same logical domain and all that stuff. So this is the list of the nodes in my cluster. It's giving me the age, which I just stood up this cluster 46 minutes ago, slightly before Kash, or slightly after Kash started. I want to see if I'm good on time, if I can actually run through this whole demo. How much longer do I have here?
We have the space till 9, so I don't know how much time you guys need to give some intro.
Okay.
Yeah.
Yeah, I actually have like 4 minutes left until the 8:30 to 8 to 8:30 intro. How are you planning on using that, Kash, as far as like intro?
Just 15 minutes just to go run the 566 and I can help.
Okay, got it. So let me see. Maybe I can just give you guys like sort of a quick demo of like this hello world for the Node app. So what I'm going to do here is basically say, run this container image for hello world, and I'm going to expose that on port 8080. And you can see this is super simple. Kubernetes has sort of a kubectl run, something sort of syntax. It's very similar to the Docker run. vocabulary and sort of, command line syntax, and they try to keep fidelity there. Again, we're not giving you direct access to the Docker command line, Docker API here. We try and level that up, and that's a separate sort of workflow within Kubernetes to sort of remove you from this management of containers directly. We want to have you manage your applications and sort of how those things work together as opposed to managing containers. It's a much more powerful abstraction. So beyond that, we want to basically expose that container. So we're basically giving it an expose command. So that's opening up the container to the outside world.
The image comes from Docker Hub?
No, we're actually pulling this from a secured container registry, which is hosted by Google, the Google Container Registry. So that's GCR.io. So you can check that out. That's Google's hosted Docker Container Registry, basically.
And how do the images are supported inside? Is it like the majority of the good images?
Yeah. Those are secure and trusted images there. We typically, as Schismatic, we typically recommend against people pulling images directly from Docker Hub because of sort of versioning and security issues, and people just basically do a quick prototype and they throw it up there, and you want to pull something down, you have no idea what you're going to get, and it's like lots of mystery soup going on there. So we've exposed that container. Now we want to basically get at that service. So kubectl is getting us a service. Now we are given an IP, which again, as I was talking about, is generated from that kube proxy agent, which is on the nodes, talking to IP tables. And so we never really need to think about this IP. It's generating it automatically for us. So it's that really nice command line that gives us the container exposed on port 8080. You'll notice here we also have a column for external IPs. This is giving us an internal cluster IP only. If we wanted to have an external IP, we would just basically say, type external IP, or I think it's type external IP, and that would basically give us an external IP that we can reach from the outside world, outside of the cluster. Beyond that, we can basically look at our application here, and it's not giving me that. It says it might take a few minutes here, so you might hit that again. And did I just? Yeah, I just deployed that here. So, obviously, what I'm doing now. Got to just basically copy that and then do 8080.
So this is a single container wrapped in one pod.
Right.
When it deploys the container, how does it pick the machine? Does it look at load characteristics?
It doesn't. It's just giving you the basic round robin. I mean, you can have the container deployed based on node level utilization, which is like a scheduling heuristic kind of thing, and it's basically saying, what is the actual current utilization in terms of CPU, memory, and RAM on the nodes deployed on the least utilized node, and that's sort of a least used algorithm. There's a lot of other really advanced algorithms that let you do things much more smartly than that, and look at like bin packing things based on priority and preemption and constraints and response times and bunch of concurrent connections, a bunch of different things, and you can feed that data into Kubernetes. But the basic algorithm is just round robin. So I basically point my my browser to that IP, and should be serving that to me here in a minute. Still spinning. And yeah, I mean that's a really basic example. For some reason it's not. Maybe I've got a firewall issue on my machine here. That has worked before.
Can you tell them that to it?
Sorry?
See if you can tell them that to it.
Yeah.
You can access it.
No, Space 88.
Space water.
Yeah.
Space 88.
Try pinging it.
Can you see the IP?
That's really weird. Anyways, it should be giving us that.
Demo guys aren't happy with
Yeah, they're not happy for some reason. Anyhow, I trust this is like the absolute most basic possible Kubernetes demo ever. It definitely works.
The external IP. External IP might be different.
Yeah.
If you go there, you don't have external IP in that class in here, I guess. It's blank, right? We need that IP.
What's the external IP?
We need external IP or the cluster IP.
Oh yeah, you're right. So
10.11 doesn't look like an external IP.
that's weird.
Maybe good balance.
Huh.
Is that the end?
So it's basically giving me like a random string here for the pod name, and I'm trying to find out if actually hang on here. So if I make that, if I change that service config to
Would that be a DM?
I think there it is. Yeah.
Yeah.
Yeah, this.
Hello Kubernetes.
So would this setup handle like health monitoring if the node died? Or you have to
Yes.
build more into it?
Yes. So by default, pods auto restart. So this is really basic. I did not have any replication controllers here.
Right.
But by default, your pods always auto restart. So there's a restart policy config in the pods that basically says always. And if you change that to never, the pod dies or terminates or crashes, it's just going to die and terminate. And that's like a really manual way of basically running like a batch operation or something. There's an actual like API object for running batch things, which gives you like a way to do that more cleanly. But this is just literally a way to run a pod and get to it to prove that Kubernetes is real and that it works. But yeah, we can go a lot deeper here. I don't want to take too much more time. Hopefully this was useful for you guys, just kind of like a really super high level one-on-one. Yeah. go ahead.
In the different pods, is there any restriction from them keeping the same Docker container within them? For example, like auth is used by almost everybody. For example, you may have one Docker container that does the auth service, and all these other things use the auth service, for example, so all the pods, is there any reason the pods can't share, or do they have to have their own instance of everything?
So pods are basically like recreating those containers, and so you could have.
Oh, so they don't have a separation between different pods.
Well, so the containers running in pods are separated from each other, but they can be the exact same containers. They're pulling from the exact same
different
image.
instances, right? Okay.
Yeah,
Okay.
yeah, they're just different instances. So you want to be pulling from a different container image. You want to have distinct containers pulling from different, different software libraries or binaries, what have you.
Mm-hmm.
Does that make sense?
Yeah. Okay. Yeah. So there's no way to guarantee. For example, you want to be sure that a given container is the same across all pods.
Yeah, you absolutely can if you have the same image that you're pulling from. So you're basically
Right. By using the source being the same.
Right, exactly.
Okay.
Yeah. Anybody else?
Yeah, I wanted to know, can we maintain the pods automatically, like on demand, another month more, beginning the month, yes, like that?
Oh, you mean like scale them a little bit? Yeah.
Schedule time.
You can definitely scale them based on load. Right now, you can't scale them based on like time. So I think you were saying like I want X number of pods available at a certain time period and less.
Less pods on a minute to the month where not very less activity. Like that.
Yeah, we can definitely scale based on the load right now and based on different metrics that you provide.
Okay.
We can't scale pods yet based on sort of like a cron schedule, like a time-based schedule. There's ways to kind of hack around that with light scripting.
Some script and like that.
Sure. Yeah, that's easy.
Yeah.
But not natively. Not natively. Natively, it's much more around load and different metrics that you provide. Yeah.
Yeah. Container from one pod talk to another container in another pod as a networking
Mm-hmm.
overlay.
Yeah, you definitely can. I mean, that's really where you have the service abstraction. So you want to be directing things directly into those those pods that are basically grouped behind the same service. You can also have explicit consistency of IPs for different pods, and so you can basically have them on the same subnet domain, and they're all on the same subnet domain in a cluster. But you can have there's basically ways to do that with like overlay and layer 3 type tools that are provided as additional components. We didn't really get into any of that here at all, but a lot of people use things like Flannel for doing things that you just mentioned.
For services, is there granularity in terms of ports? Could I make a service IP port 80 go to one pod and port 90 go to another?
You absolutely can.
Okay.
Yeah. So there are there's definitely a way to do that as well. I mean, there's ways to even do that at the DNS level, where you have sort of specific domain pointing to a group of backend pods and another one to a different group. Anyone else? Cool. That's pretty much all I have. I mean, not much beyond that for 101. I mean, we can get if you're interested in getting into some of the introductory tutorials on the Google Cloud website, I just encourage you guys to check out. There's a Hello World Node.js one, which gets into the container registry that I was pulling that one container from, and then the Cloud Shell, which I mentioned is where you basically pull your Docker files into a Kubernetes cluster and run those, and then this all just goes through all those different instructions for setting up your cluster name and your Docker file configurations and all that good stuff. A little more lengthy than what I just did, so hence not going through one of these. But these are really great and give you a lot of hands-on experience with some of the additional primitives that I was talking about earlier around services, replication controllers, and namespaces as well. So namespaces gives you sort of a sliced view of your cluster in terms of resources and CPU, and you can sort of provide access to namespaces inside of a single logical cluster for different users. There's lots of different things in Kubernetes that let you do some pretty cool stuff. So thanks, guys. That's pretty much all I have.
Real quick, so you saw Kubernetes is like Google's way of managing containers and having them in production. And I wanted to show you Cloud 66, which is what we built for our clients. It's a service that you can sign up to, and basically we connect your code repository and we build it into containers for you with something called Build Grid, and it obviously uses Habitus. Then we fire up the servers that you need on any cloud provider of your choice, or bare metal, or any other server. Then we do scheduling, rollout, management, monitoring, and then we also take care of your databases outside the containers. We do replication across data centers, providing networking. So basically, A to Z, soup to nuts, everything you need to run containers in production. And we do a lot of dog fooding, drinking our own champagne, however you want to call that. This is Cloud 66, my account, or actually engineering account, as you can see. But I'm going to show you one concept here. So what we have we call the stack, and it's basically multi-tenanted containers management. So one of the things that we have here, for example, is our metric system runs with Cloud 66. So we deploy Cloud 66 with Cloud 66. And Cloud 66 essentially is just container management as a service. So as you can see, here we have a Docker cluster, which is a bunch of servers that we have that run our containers. We have RabbitMQ, we have InfluxDB, and we have a custom server, which is just any custom server that we want to have things on the Linux server. If I go to our Docker cluster, I'll see that these are different services that we have. The different servers that we are using for to provide our metric system, for example. I can go to each one of them. These are the services that I'm running. I can scale them up and down. More containers of this service. I can just click scale and it will do it. Obviously, I'm not going to do that in production. Demo gods showed that I'm not very happy, so I'm not going to risk it. But basically, what you do is, if you get a compose file, you can basically drop it onto Cloud 66. And what happens based on that, you can say, my services come from this image that my CI/CD builds as an artifact, Maven, whatever that might be, builds it as a container image that's in S3 repository or my Docker Hub or wherever else. I want you to pull that and build the service format, or you can say, I don't have a container for it, I have a Git repository, and this is the key for it, and this is the branch that I want you to go there. What happens, Cloud 66 gets to work at that point? It starts, goes to your code repository, takes your code out, runs your Docker file. If you have a build YAML, use habitus to build the container. Then it provides you with a private repository, a Docker repository that puts that image that we built into it. Then it connects to your cloud provider of choice under your own account. Let's say you're using DigitalOcean or Rackspace. I connect to Rackspace. We fire up with your credentials under your own account all the servers that you need. We then pull the image that we built or your own images that are stored in your own repository onto all the servers. Fire them up. We put load balancing in front of it, so you can connect that. We provide a network that runs across data centers and across different cloud providers as well. So you can have a secure network across all of those. The traffic then flows from outside to your containers. It does service discovery with DNS, so you can have, like my web can pull my API and talk to the API. As well as that, if you have a database that's detected by Cloud 66, like MySQL, Postgres, MongoDB, Redis, Elasticsearch, Memcached, all of those are supported. RabbitMQ as well. We fire up a VM or a bunch of VMs. We fire up those servers. We provision them, and things like you can do things, quite cool things like this. If I go to, for example, my Docker cluster, I can actually configure my Nginx right here with a template. So if you imagine you have all those containers running. All of them serve traffic, and there's an Nginx sitting on top of it, distributing traffic between those. Now you want to have something like, I want to have this header, or whatever else that you want to have. This is Nginx configuration that you're familiar with probably. But as you can see, it's got these templating things, which is a liquid template, something that Shopify developed. So you can have all those here, and I just press preview. I see what it looks like at the end. And then I can just add comments and deploy it. You can alternatively use it as a Git repository, which is here. You can pull it locally, and you deploy it. And what happens is basically it goes to all of your servers and updates it. The beauty of it is the configuration for your load balancer, for example, comes from a template. It gets pushed out. As well as that, let's say tomorrow there is another heartbleed, or we hear about NSA activities, so you want to have perfect form secrecy, whatever that might be. If Cloud 66, you opt into that, we patch that Nginx configuration, for example, for you, and we merge it as another developer in your team into your branch so you can approve it, and it just goes out to all of your servers without any need to change anything. If there's a conflict, you will be notified, and better than that, if one of your, one weekend there is a fire and somebody jumps on a server just to sell something, as we do, we always do, we know that, as much as we want to deny it, somebody jumps on a server and fixes something. We notice all the discrepancy between that, we bring it up to your attention, we say, you want to make it canonical, you want that to be the thing, or you want to revert it back. So this whole control loop actually exists not only at the container level, but also at the configuration level for every single component that Cloud 66 deploys for you. There's Nginx, MySQL, Postgres, Memcached, Redis, MongoDB, whatever, InfluxDB, all of those. As well as that, as you can see, here, under my stacks, for example, if I go to metrics, I have a deploy flow. So I can say I want to deploy all of my services, or I want to create a new profile, which basically says, these are my services. This profile means I want to build these and publish only that. I give it the name, when I save it, my developers can actually go and deploy rollout. So there's a lot of work that you can do into customization of your deploy workflow. And you can hook it up into your commit CI when you go to get a green test from Circle CI, for example. After you commit code, it goes into production. You can do all those sort of things with deployment. As well as that, you have access to firewall control, which is kind of much simpler than doing it manually, obviously. So I can go and say any traffic coming from any of my servers here, or any other stacks, so you can have cross-stack firewall settings. Any traffic that comes from my Docker servers that goes to InfluxDB on whatever port is okay. So if I go and add another server to that cluster, my firewall automatically gets updated, and it actually works across different stacks. So there's a lot of firewall management going on, as well as what we call Active Protect, which basically looks for bad things, as in file changing, known vulnerabilities, Any blocked connections, something very similar to fail to ban when there's an attack, like an all service or brute force attack. Or any files change, which is what we talked about any configuration file that might be changed. You can control over environment variables. And also, this is the two parts. So service YAML is very much similar to Compose. Docker Compose, as you can see, this is my application. I have different services. This is where they come from in terms of Git, the command that I need to run it. You can also have very fine control over start and stop of the containers, like pre-stop sequence. I want to send a USR2 for 10 seconds, wait for it to die. If it didn't, the term, and then 10 seconds there, and then I'll brute force kill it, because sometimes things like this happen. The stop grace is 10 seconds, what ports are available on what protocol. Then there's another one, another service, another service, another service. As you can see here, that's the difference between this and Docker Compose. You have databases, RabbitMQ and Influx. As soon as I have that, it means I want RabbitMQ, and we deploy RabbitMQ, or Influx, we deploy Influx. You have version control, obviously, for that, all of it. And then there's manifest, which is basically the ops side of things, where you say, this is where I'm deploying things. This is on Amazon. This is my VPC, so we can deploy onto a VPC, and everything else around the size of the servers that you want and everything else. So you have developers and ops both working in lockstep, but completely separate in terms of who can access what. As well as that, you can use Bastion servers. You can put the Bastion server in front of the VPC. You can do all sorts of different configuration, and have a complete hybrid setup of public and private cloud if you want. Again, you can have fine control over deployments. So as you can see here, these are the builds that happened, and some of them have gone to publish. So this publish failed. This one, you can go back, rebuild it, republish, so that you have fine control over the containers that are going out, the code that's going into each one of them, and every container that serves traffic, and you can all the way go back to the code that's contributed to that. Also, we have something called live logs, which is all the components that I have from Nginx, Rabbit, databases, and all my services that I can tap into, and then the logs will start flowing into this, so I can actually use it for debugging if I want to see, which is quite useful when you have a lot of containers that you want to filter things based on and see what's going on. All of this is available as a service, obviously. You can use it by signing up to cloud66.com, and you can have multiple organizations as well, which are completely separate. So we have a lot of customers who are consultants who work for multiple different companies, and they want to have their infrastructure management separate. You have all those sort of things around, for example, audit, who logged in when, what happened, when they changed an environment variable on a server, all sorts of things. You can actually search for it. Teams, organizations with fine-grained ACL control over who can deploy, who can look at the server, who can access any server, who can SSH with a command line and API and everything else. So that's basically Cloud 66. Just wanted to show you what we do. And for the last part, this is our app store where you can just click on, for example, Elk Stack, which is Elasticsearch, Logstash, and Kibana for log management, and it just pre-fills all those things for you, all the kind of services that you want, all the ports, everything else, database that you need. You click next. I have a stack with that, so I'm going to call this something else. And then once we have the analysis, then I can choose where to deploy it. And these are my cloud accounts. These are not Cloud 66's. This is my personal cloud accounts that I have with all these cloud providers. Or I can say deploy to my register service, which is basically a pool of ops service that I might have on like Pets, some code or somewhere. So I choose what I want. Let me choose Rackspace, where I want to deploy it. So I have only London access to Rackspace. That's on because it's my account. I choose the server type. Then I say I want my Docker on a cloud server, or I want a hybrid. So I want my Docker servers to be like bare metal. Elastic server, I want to share it with my Docker server because I'm cheapskate. I don't want to spend too much money probably. And then I'm going to say deploy, which basically goes and does the job. So now it's going to fire up servers on Rackspace, London. build the containers for me from the source code, the images, roll them out. Then I say load balance, it does the load balancing based on the cloud native provider that I choose. So Rackspace, they do load balancing, so we do that. If you run DigitalOcean, we do HA proxy cluster for you. So for you, you can move one stack from one cloud provider to another cloud provider without any, with complete abstraction, so you don't need to really worry about where it's going. As well as that, you can do cool things like failover groups, which is actually developed for a very cool customer that we have. So we have a customer who with a Geiger counter, which looks at, counts the radioactivity on top of a mobile phone, and they put it on a quadcopter, and then they fly these things around nuclear waste zones or nuclear disaster areas. They actually started in 2011 after Fukushima. So they fly these things and then send a live read of the Geiger counter into Google Maps, and they superimpose it so the workers know where to go when the wind is blowing, for example, bringing radioactivity particles. And naturally, because they work in disaster areas, they wanted to have deployment of that for Fukushima onto Amazon Singapore with a backup into Rackspace Dallas. So for that, we created failover groups where you can create a unique URL here and say what's the primary stack for it and what's the secondary. And as soon as the primary goes down, let's say the whole data center is wiped out because of a tsunami, as it happened back in 2011, it switches the whole thing over, and they've actually been using this at that scale. The other thing that they used it for was when there was another customer of ours actually ran it for a campaign for Syrian refugees, where the Syrian cyber army basically attacked one data center and then switched it over somewhere else because of a campaign that was backed by Google and Richard Branson, and it was high profile, so the Syrian government didn't want them to gain publicity, but they dodged it with this. It's one of the proud moments. And obviously you have the registered servers where you just run one line on your servers where you can download the scripts and drop it onto the servers, and they start showing up at this point, and it will become available as a pool of resources that you can deploy containers onto. So that's Cloud 66. Check it out if you want. You can try it for free. And well, I'm not going to wait for the whole stack to show up, but you can try it for free and just see how it works.
What's the driver for pricing for the platform? Is it number of servers,
number of servers. If you're using for development, it's free. If you label your stack as development, it's free. Whatever you call development, it's up to you. As long as you say it's development, it's free. It's per server per month. It's $9 per server per month, so it's very cheap. And if you have a team, then it's, I think, $2 per team member per month. We also do replication of database and backup verification. So if you have a database, you can say what cron schedule you want to have the backups, and you can have backups across all your databases, like your Elasticsearch and your MySQL at the same time, which kind of gives you like a time machine, like a snapshot of that application, which you can go back to and revert back and restarts the app with the same data as if you just pull the whole app back, which is quite cool when you have containers that can work with the code, but the database migration, schema migration, that kind of goes back in time. And that then can be replicated. So we do replication instead of just basically scale your database, which is replication. And it creates a replication and it monitors the replication so the database doesn't deviate, the databases don't deviate. As well as that, the backups get pulled into a server. You give us a script into your code, and we run that script to make sure the backup is verified as well. Because something happens, and then you know that you didn't back up the whole thing. And that is per gigabyte per month of the storage, if you choose to use Cloud 66 managed backups. If you bring your own cloud provider storage, like S3 or Rackspace files, you have an agreement with your cloud providers. So that's it. Any questions, any comments? Cool. Thank you very much.